Okay, in this short video we're going to look at units, prefixes and engineering notation, and this is a very important subject because it's also the first thing we do in mechanical principles, and that's because the importance is you're going to be using it all year in your calculations, and if you don't get comfortable with it at the start, you're going to have difficulty later on when you try to do those calculations. Some examples would be, say you've got 80 kilonewtons. Okay, we've got a unit here, and we're going to talk about units later on this video, and a prefix. So that prefix actually means 1,000, so that's times 10 to the 3 newtons. And this is the engineering notation part, and that's the equivalent of 80,000 newtons. Okay, 25 millimeters. Okay, you'll be familiar with meters and millimeters. And meters, the milli part in front means times 10 to the minus 3. So we have 25 times 10 to the minus 3 meters. Okay, and that's equal to 0.025 meters. Okay, and one other example, one you probably haven't seen before, 50 micrometers. That prefix is times 10 to the minus 6 meters, and that will be 0. And then 4 zeros, 5 meters. Okay, so in each one of these cases we've got a scientific notation, we have a prefix, okay, and we have the units as well, and that's what we're going to look at in this video, explaining what the base units are, some derived units, and then looking at the prefixes and how to work out what that means. Well, if we look at the base units now, the basic SI units are the meter, okay, symbol M, and that's for obviously length, kilogram, kg and mass, time is second, and current is ampere. And although we use degrees C for everyday temperature measurements, in engineering we use Kelvin, especially in the thermodynamics section that we'll be doing later in the course. And for the brightness of lamps and light sources, the candela is the unit that measures luminous intensity, or how bright something is. And in chemistry you're probably familiar with the mole, which is the measurement of a substance. Now, SI stands for System International d'Unités, and it is basically an agreement that was based in France. Now, in museums you can see samples of say this is the kilogram, so it's a little block of metal held in a vacuum, and that's what they based their measurement off. Okay, this picture here shows you the kilogram and the meter. Okay, and it's a platinum rod with 2 lines on it, and they decided that a meter was the distance between the 2 lines on this platinum rod with 10% iridium, and it had to be measured at the melting point of ice, so that was 0 degrees C. So you can see that it's really humans who have set up what these mean, and in ancient times they used their hands to measure things, and they had measuring rods and stuff, and things haven't changed that much. We've just decided on a different unit and a reference point for that. Okay, now if we look at the derived units, if you remember, we were talking about base units of a meter. Here we have area, and notation is meters squared. So if you imagine a shape like a square, and we have a length on one side and a length on the other, you multiply both sides, you get meters times meters, which is meters squared. So that's the unit for area. Volume, okay, similarly we've got 3 measurements. 1, 2, 3, one along here, one up and down and into the page. So we've got meters times meters times meters, which is meters cubed. Okay, so that's volume and that's area. Okay. Okay, a slightly more complicated example is the unit for force. Okay, it is a Newton, and you'll be learning later in the course that force is equal to mass times acceleration. Okay, now mass is measured in kilograms and acceleration is meters per second squared. Okay, so the unit for newtons is a kilogram meter per second squared. Okay, and that is what a newton means, but quite often in engineering we use there's a watt, there's a newton, there's a joule, should have an O in there. We use another name for it to simplify it, because instead of saying kilogram meters per second squared every time, we actually just say so many newtons as the force. Okay, so that is basic units and derived units, and it's probably a good idea to stop the video there and start another one for engineering notation and prefixes. Okay.